So the next topic is how to do plotting in MATLAB. So let's do that. By the way, that resistance exercise that you're going to do, again, make sure you, well, there's a function that you have to create later on. Next week, we're going to discuss functions. So make sure you keep that function with you, because when you're taking your circuits class, you can use that function to calculate the equivalent resistance parallel, and that's going to make your life very easy instead of spending time and using your calculator or something. I don't know if I'll be teaching circuit analysis or someone else will be teaching it when you take it, but when I teach it, I ask you to use all these functions that that you are using in this class. All right, so plotting. Plotting in MATLAB, the function is plot, very simple. And the plot function is going to plot x versus y. So simply, you have an x vector, 1, 2, 3, 5, 7, 8, and then you have a y vector of the same length, 4, 8, 9, 13, 19. And if you just do plot x comma y, then it's going to plot each point of x versus each point of, well, the vectors are different length, seems like it. 1, 2, 3, 4, 5, 6, and yeah, y is 5. So let me change y to 6 values, 67. So it's going to plot each plot of x versus each plot of each point of y, and it's going to connect those points using straight lines. If you don't want to connect them with the straight lines, then you can use, let's say if you want to put O, then it's just going to show those points in O. So it's going to show individual points as O's and not connect them. Now, most of the time, if you're collecting data from, let's say, your lab experiment and stuff, and you have to plot it, then this is how you're going to plot it. Plot current, comma, voltage, whatever. If you're plotting equations, then first you have to evaluate the equation, and then you have to plot the equation. So let's say, let me go to my editor, and let's give you an example. Let's create another. This is an example of 2D plots in Octave or MATLAB. And let's save this thing as MATLAB 3. So let's say you are, let's say, plot f1x equals 2x cosine of x plus 3 sine of 5x. Let's say you want to plot this equation, 2x cosine of x plus 3 sine of x, for x is equal to 0 to 5 with a step size of 0.01. So you want to plot 2x cosine x plus 3 sine 5x. You want to go from 0 to 5 for the values of x with a step size of 0.01. So first you have to evaluate the equation for the range of x, and then you have to plot it. So to evaluate the equation, of course, first you have to define the vector x. X is equal to the starting value, 0.01 interval, and the final value, 5. That's going to define your x vector. Starting value, interval, and final value, and colon between them. And then I'm going to write f1 is equal to, now let me write this equation, and I'm going to ask if I have to do anything about this equation. So let's say 2 times x times cosine of x plus 3 times sine of 5. All right, who's going to tell me if the equation is written correctly or incorrectly? If the equation is written correctly or incorrectly?
I think it's correct because you got no vectors.
Same, yeah. I think it's.
All right. Anyone think that it is not correct?
Are we going to be using vectors? Because then we need periods.
Is X a vector or not?
Oh.
No, I think it's just a scalar quantity. It's not a.
How X is a scalar quantity? It's 0 to 5 with the interval
Oh,
1.
yeah. Sorry. Yeah.
So is this correct incorrectly or not?
No.
All right. So what should I do to correct this?
Add periods in front of any multiplication or division. There's only multiplication.
All right. So where exactly I'm going to put a period in this equation?
You know how to do it for the constants. There's one, like the x times the cosine x.
Right. There's only going to be one period right over here. That's about it.
Yeah.
That's it. Yep. Now it is correct. Okay. So it's going to evaluate this. And now I'm going to call it figure 1. So you can define different figure numbers, and those figure that you're defining with the number, that's where the plot is going to be plotted. So my figure 1, because I'm going to do multiple plots as well. So figure 1 is the first one, plot x comma f1, and I'm going to do something else as well. I'm going to use a function line width. Now what line width does is it increases the width of the line with which you're plotting the function. And I'm going to say line width is 2. So the default line width I think is 0.5. So I'm going to increase it to 2. So it will be bolder line. And I'm going to say what should be written on the x-axis. And the function is x label. Whatever you want to label on the x-axis, you're going to put it as a string. So that x label, let's say, is my x value. So I'm just going to put x is my x label. And likewise, whatever you want to put on the y label, y-axis, you can put it as y label as a string. And let's say if I put my y label is f_1x. Now, whenever you're putting a string in the x label or y label, and also on the title of the graph, let's say title. And let's say if I put f1x equals 3x sine x, 3x cosine x, 3x cosine x plus, or that's 2x cosine x plus 3 sine 5x. So you can put label on the x-axis using x label, label on the y-axis using y label, and you can put a title on your plot using the title function. And anytime in the string of x label, y label, or title, you are going to use underscore. Any character that is written after underscore is going to be, it's going to make it a subscript. So it's going to be f, subscript is going to be 1 and x. And anything that you write after the caret sign, the next character after the caret sign is going to make it a superscript. So it's going to raise it to the power. Anything that you want to write in x label, y label, or title. Also, if you want to write Greek characters, for example, if you are in resistance values and you want to put ohms as the symbol of resistor omega, then what you have to do is you, in the x label, y label, or title, wherever, if you put backslash and the name of that Greek character. So if you put omega, O-M-E-G-A, with O uppercase or lowercase. Uppercase omega is going to print the uppercase omega symbol, and lowercase omega is going to print the lowercase omega symbol. So you can have pretty good flexibility when you're putting the labeling, when you're doing labeling on the X label, Y label, or title. But underscore is going to make it subscript, the character after that, and character function, the power function, power character is going to make it the superscript. Now, if you have multiple characters that you want to do, let me run this and then discuss the multiple characters. So let's go ahead and run this now. And this is my plot for this function, as you can see. Going from 0 to 5 on the x-axis with an interval of 0.01. f1x is my y label, x is my very small, x is my x label, and f1x, and again look, 1 is subscript in the title as well as that. I don't know if we can increase the font in the title. I never did that. Maybe there's a way to increase the font size in the title. I'll check online. But if you can find online how to increase the font size of the, because these are quite small. I'm assuming there should be a way to increase the font size. Like we are changing the width of the line. Now, as far as plotting is concerned, as I showed you, you can plot using O's, like different characters. The default is just a dash. It's going to plot everything with a dash, and it's going to connect the consecutive points with the straight lines. If you look at the help plot, then you can see that these are all the characters that you can use. So line style, the default line style is just a dash. You can use 2 dashes for the dashed line. You can use dot, colon, that is for the dotted line. You can use dash and dot for the dash dotted line. And you can use markers. I showed you the marker of circle, 0, or O, sorry. You can use plus sign, you can use asterisk, cross, all those things as marker. So it's going to print those points using these markers. You can use different colors as well. The default color is blue for the first plot. If you're plotting multiple plots in the same graph, then it's going to automatically change the color of each plot, but you can change it manually as well. For example, right now the default color is blue, but if you want to change it to, let's say, magenta, so you're going to go to your code. You're going to go to your code, and all you have to do is write down after y m, then, and that will change the color of the line to magenta. Let's run it again. And the color will be changed to the magenta color. If you want to put M and power sign, then the plot is going to be plotted using, as you can see, the power symbol is upward facing triangle. So it's going to take upward facing triangle and then plot your plot using upward facing triangle. So all these points are plotted up with upward facing triangle in the magenta color. Let's say if you want to plot with green color and with circles, G and green, G is for green, O is for circle, and all the points are plotted using circles. That's why it looks so thick. And if you just want to plot in different color with the default dash, or let's say you want to plot green color and dash and dot. So it's going to plot that using dash and dot. So multiple options are available to change the formatting of the line with which you're plotting it. The default color, as I said, is blue. And if you're plotting multiple plots in the same window, it's going to change the color of the line automatically, but you can also change it manually. These are all the options available, as you can see. As far as coloring is concerned, you have red, green, red, black, red, green, blue, yellow, magenta, cyan, and white. There can be more help for MATLAB. If you go to the MATLAB online help, then you can see a lot more help for plot function. But this is also good amount of help available in Octave for. So, anyways, going back. So this is a single graph plot. You're plotting single plot. What if you want to plot two plots in two different figures? We can do that as well. Let's say we want to plot F1 and then plot F2 equals, let's say 5, 2. So let me keep it as 3. So 3 sine 5x cosine 3x plus 2x. Let's say you want to plot like this. Then again, first you are going to evaluate. Then let's say that range is the same as you did. You can have same range or you can different range, different vector. Let's assume you have the same vector. If it's a different vector, you have to define that vector as well. So 3 times sine of 5x cosine of 3x plus 2x. All right. Is it written correctly or incorrectly? Who's going to tell me?
Isn't there supposed to be a period between the x and the cosine?
Between sine 5x and cosine 3x?
Yes.
Okay, yeah, there has to be. And that's a mistake in here. So that was written incorrectly, and the correct equation has to be written. Because, of course, sine 5x is going to give you a vector, and cosine 3x is going to give you a vector as well. All right, so now you want to print it in a separate window. So you're going to define that. I'm going to plot it in figure number 2. And I'm going to copy this thing instead of typing it again and modify it. And then plot x comma f2. And let's say I want to plot it with a different color, not the same. So let me plot it with magenta color. X f2 of x. And f2 of x is this. So I'm just going to go ahead and copy this and put it here. This is f2 of x. I'm going to put this and save. Run it again. So now I have two plots. Figure number 1, as you can see, this is figure number 1 right here on top, and figure number 2 right here on top. So figure number 1 is this plot right here, and figure number 2 is this plot right here. Again, you can change the range of x for each plot. You just have to define them separately and then use the appropriate variable. Let's say you can call it x1 for f1 and x2 for f2 if they're different. If you have oh yeah, I was showing you, if you have multiple characters that in the label or in the title you want to make subscript or superscript, then how do you do that? So if you have multiple characters, let's say you have f11, then what you're gonna do is you're gonna put that in braces after the underscore. And once you do that, all the characters that are written in the braces after the underscore, they're gonna become subscript. If you don't do that, only the following character after the underscore is gonna become subscript, not any other character. So in this case, how to see, I think. In this case, F11 right here. So F11, both 1 became subscript. So if you have multiple characters to either make superscript in the title label or labels, then use the braces, and inside the braces, all those characters should be written right after the underscore sign, and to raise it, to make it superscript, right after the power sign. if you have to, as I mentioned, if you have to print a Greek character, then all you have to do, let's say if you want to print alpha, so you're going to do ALPHA after backslash, either in X label, Y label, title. Let's say I put backslash omega. If I do that, then again, very small, but you can see that omega character is printed here. Why it's not printing alpha? Let me go and check. It's not printing alpha. I should print alpha. It's printing omega. Let's do alpha. Maybe it's only a few characters it does it. It printed alpha, the lowercase alpha. Why? I don't know why it did not print the uppercase alpha. It's printing the uppercase omega right here. That's interesting. Let's try one more time. Backslash alpha. All right. Let's run it. Yeah, for some reason it's not printing uppercase alpha. Interesting. I didn't realize it. Others. But that's how you print the Greek characters. I didn't know that it did not print uppercase alpha. It's printing lowercase alpha for sure, and it's printing omega. But backslash and the character name, and it's going to print that character. Okay. Any questions so far about plots of a function, separate plots of a function? If you want to plot both of them in the same figure, how are you going to do that? So figure 3. Now you're plotting both of them in the same figure, and I'm going to plot that in figure 3. And again, it's going to be the same thing. Plot x, comma f1 for the first plot. Again, I'm going to change the line width to make it a little thicker, and I would advise you to do that as well when you're plotting. And then plot comma x, comma f2. And if x is different for the first one and second, then you're going to just write down x1, comma f1 and x2, comma f2. And that's how you do plotting of multiple functions in the same figure, just by doing x, comma y1, comma x, comma y2, comma x, comma y3, or x1, comma y1, comma x2, comma y2, comma x2, comma y3. Of course, line width I'm putting to increase the width. You can change color. Although when you plot different plots in the same figure, the colors will be assigned automatically. Different colors will be assigned automatically. X label x, y label f1x, and f2x. And title, let me put the title of both functions. F1x is this. F1x. And F2x is that. So F1x is this, and F2x is this. But maybe I put an and symbol instead of writing and F2x is that. All right. So this is the third figure with both functions printed in the same figure, both F1x and F2x. By the way, observe at the bottom of the figure, these are X and Y coordinates. So if you put your mouse anywhere on the graph, it's going to show you the X value corresponding to that point and Y value corresponding to that point. In MATLAB, you can move your mouse along the graph. And this is free. You can move it anywhere. But in MATLAB, you can move it along any graph that you choose, and you can only read points along that graph. Octave is free. So if you want to read a value, you'd really have to just go close to that value and then look at the X value and observe what is the Y value for that. So this is if you want to plot both of them. Observe that it assigned colors automatically, different colors automatically, but did not print out both of them in either red or blue. When you're plotting multiple plots in the same figure, sometime it will be hard, or actually most of the time, a person who is looking at the plot would not know which plot belongs to what function. So whenever you're plotting multiple plots in the same figure, it's always important to assign a legend to each plot. And the way you do that is legend function f1x and f2x. So in the legend function, separated by a comma, you can put strings, characters, to represent the first string will correspond to the first graph. So it's going to show you basically that this is the part of this color is used to do the first plotting. I don't really need to use comma here. So when I run this thing, so now observe right here in the corner, it is showing me that blue line is f1x and red line is f2x. And again, in MATLAB, you can move this anywhere. And Octave, it is just on the right-hand side on the top corner. You can put the legend in the same line, just put comma and then put legend after that. You don't have to put it in the next line, but if you're putting in the next line, then you can also do that. So figure 1, figure 2, figure 3, 3 figures. Figure 1 is f1x, figure 2 is f2x, figure 3 is both of them in the same one. Then the last thing I want to discuss about plot is how to divide one figure into multiple figures and then plot each one of them in different figures. So it is called subplotting. So let's say figure 4. Let's say you want to divide one figure into 3 plots, 3 subplots. And then in the first plot, you're going to do f1. In the second plot, you're going to do f2. And in the third plot, you're going to plot both of them together. So the function is first you put subplot. And then you define how many figures you want to divide, how many subplots you want to divide the figure into. How many rows and how many columns. So number of rows, let's say I want 3 rows and I want 1 column. And in which figure, subfigure or subplot you want to plot the current figure. So let's say I want to plot the current figure into in my first figure. And then all you have to do is to use the figure and plot it in there. So subplot 3, 1, 1 means it has 3 rows. Figure 4 is going to be divided into 3 rows, 1 column. And in the first plot from the top, I'm going to plot f1. Likewise, subplot 3, 1, 2, 3 rows, 1 column, which will be the same for each subplot. But now in figure number 2, I'm going to be plotting my x of 2, f of 2. And finally, my last figure, subplot 3, 1, 3. I'm going to be plotting both of them together. Now, if I run this thing, 1, 2, 3, and 4, this is the subplots. So it divided the figure into 3 rows, 1 column, f1 in the top, f2 in the middle, and both of them at the bottom. So in PSpice, if you remember, it was adding a, what was that? Adding a plot to the figure. You used to do the same thing. You add plot to the figure, divide one figure into multiple plots. It's the same thing as doing that. This is a subplotting. Any questions so far? I don't know if you're working with me or not, but if you're working with me, that's awesome. That means I will not see any problems in your homework, most likely. All right, let's see what other problems you have to do. Plotting. So we discussed plotting, example number 8. Again, I'm plotting this function. By the way, I think I discussed with you earlier as well. But remember, if you have a function like this, you have a cosine 5000t plus 70 degrees. 5000t is radians, 70 degrees is degrees. When you're evaluating this function, remember, you first convert 70 degrees into radians, and then put the time values to evaluate the phase, because half of the phase is radian, half of the phase is degrees, and you cannot add them together. So first, when you're evaluating this function, you convert 70 degrees into radians, and then put the time values to evaluate the function. So you can add both parts of your angle. But you cannot just go ahead and put the way it is written, because you cannot add degrees and radians together. And that's what you see here somewhere, 70 times pi over 180. So I'm converting the 70 degrees into radians and then using the cosine function. I did not use the line width. So it's, by the default, line width is very thin. I will advise you to use line width so that you can have thick plots. So we discussed different plots into different figures. Exercise 10, right? Exercise 10 is the next. 7, 8, 9, 10, 11, 12. Okay, so exercise 10 is the next. Ask the user to enter a vector x to evaluate and plot the following two functions in two different figures. Choose different colors for each plot and choose suitable labels for them. So you have two different functions, f1x and f2x. And you are asking user to enter the vector x over which these plots will be plotted. An example is given here. Me as a user, I entered x vector to be 0 to 5 pi with an interval of 5 pi over 100. And for that, my results are these. This was from MATLAB, the first one. This is from Octave, the second one. Multiple plots in the same figure, as we discussed in the class. So I'm plotting here two functions in the same plot, v1 and v2, which are given here in the same plot. Discussing what legend is, as you can see. Observe how big the legend is here, and this was from MATLAB. So MATLAB, the legend is pretty big. I'm pretty sure in Octave there must be a way to increase the legend size and the size of x-axis and y-axis. There must be a way. I'll find out, because these values are quite small. But I think if you, let me see, copy figure to clipboard. If you paste it, I think it still shows clearly. Oops. Yeah, if you paste it, then it shows clearly the legend, x, f1, x, f2, x, and all those things. Okay, so this is the example, and the exercise is this. Now, this exercise I'm going to discuss with you real quick. So you have this function right here. And make sure that in this function, I should have, make sure to make this, I need to go. All right. One under a square root of 1 minus zeta square is in parentheses, basically, and x is outside the parentheses. So you have this function. This is from control systems. This is a second order system. Again, not going into control systems. Assume this is the equation of a system, and this has two variables. It has a variable zeta, which is called the damping coefficient, and of course it has x, which is your x vector over which you're going to plot this function. You're going to ask the user to enter the vector x. So like we've been entering vector x, in this program, I used vector x as 0 to 5 with this interval of 0.1. Similarly, you're going to ask the user to enter the vector x in order to plot this thing. And then you are going to use 5 values of zeta, 0.1, 0.2, 0.4, 7, and 9, and plot all 5 graphs corresponding to range of x will be same for each graph, but the zeta value will be different. So you're going to plot 5 plots, one for each zeta value over the same vector of x. And the result is something like that. I'm going from 0 to 14 for my x vector. I think the interval was 0.01 or something like that. I forgot what was the interval that I took. But if I'm going from 0 to 14, then I have 5 different plots corresponding to each value of zeta. And the zeta are labeled here using the x legend. So red one is zeta 0.1, blue one is 2.2, and so on and so forth. So I'm going to get these 5 plots. At this time, what you can do is you can define 5 equations, which is a hint given over here. You can define 5 equations, y1, y2, y3, y4, and y5. And for each equation, take one value of zeta and evaluate that equation for the same vector x. So you're going to have 5 vectors. And then go ahead and plot those 5 vectors on the same graph against x, comma y1, comma x, comma y2, so on and so forth. And you're going to get these plots. So this is an exercise to plot multiple plots in the same figure, and then use legend and all those things that we are using. Just make sure that x is outside. This x is outside the square root. It's not inside the square root. Sometimes a student by mistake put x inside the square root and their results are complex, conjugate, and their graphs are incorrect. So make sure this x is outside the square root. The square root is only 1 minus zeta squared. Keep forgetting to fix that. And then we discuss subplot. Example of subplots in which I have 4 subplots. So observe 2 rows, 2 columns. 2, 2, 1, 2, 2, 2, 2, 2, 3, and 2, 2, 4. I'm plotting 4 different figures in 4 different plots in one figure. That figure is divided into 4 subplots. Exercise 12 is the same exercise as this one, except you're going to be using subplots. So do the exercise 11 for 3 zeta values, 0.3, 0.5, and 0.8. Create one figure with 4 subplots and plot y for 3 different values of zeta in 3 subplots. And the 4th subplot will be all three plots within the same figure. So you're going to have 4 subplots calculated from this equation. The first subplot, 3 subplots are going to be y1, y2, y3. And the 4th subplot will be all y1, y2, y3 in the same figure, in the same plot, like you have 5 of them here. In that, you will have 3 of them in the last one in this exercise. What else? There's an axis function given over here that I'm showing. You can also force the axis to be set between certain limits, between x values and y values. So you can also use axis in order to set your own axis instead of by default, like we had these default axes. You can set your own axis as well. There's also a really good command called axis tight. What axis tight does is, let me show you. let's say plot axis type. Axis type basically remove the white space from the graph on the x side and the y side. So what was F1, right? F1 is, this is F2. Here is F1 right here. So this is F1. As you can see, it's going to tighten up the axis. So you have y, the positive side of y and negative side of y. And all the values are between those two limits, the positive value and the negative value of y. And likewise for the x-axis, all the values are between the minimum value of x and the maximum value of x. So the axis type basically tighten up the axis and show only the plot between the limits of y and the limits of x. So sometimes it comes very handy if you don't want to show all this white space. For example, you have white space over here where there's nothing plotted. If you don't want to show that, then just do axis tight and it's only going to show up to this point. So that's another, I don't think I discussed this in the tutorial, but that's also a command. But then you can also set your axis setting, x minimum, x maximum, y minimum, y maximum as a vector in the axis function, and your axes are going to move only between those values. All right, guys, and that is going to be the end of today's meeting. I went over each exercise separately, went over everything that is already in the notes, by the way, that I discussed. But I also showed you different programs and all those things. Of course, the recording will be available. If you miss anything, you can always go back to that specific part and then look at that. Is there any question that you want to ask at this point?